Hi, hello, this is your Lucky sir. We are in NCERT text reading. Valence bond theory, orbital overlap concept. In the formation of hydrogen molecule, there is a minimum energy state when two hydrogen atoms are so near that their atomic orbitals undergo partial interpenetration. This partial merging of atomic orbitals is called overlapping of atomic orbitals, which results in the pairing of electrons. The extent of overlap decides the strength of a covalent bond. One important postulate. In general, greater the overlap, the stronger is the bond formed between the two atoms. Greater the overlap, stronger is the bond. Important postulate. Neat purpose. Therefore, according to orbital overlap concept, the formation of a covalent bond between two atoms results by pairing of electrons present in the valence shell having opposite spins. Don't worry, opposite spins will be automatically done. Directional properties of bonds. As we have already seen, the covalent bond is formed by overlapping of atomic orbitals. The molecule of hydrogen is formed due to the overlap of 1s orbitals of two hydrogen atoms. In case of polyatomic molecules like methane, ammonia and water, the geometry of the molecules is also important in addition to the bond formation. For example, why is it so that methane molecule has tetrahedral shape? Why not square planar? And HCH bond angles are 109 degrees 0.5. Why is the shape of ammonia molecule is pyramidal? Why not trigonal planar? Any other further questions? The valence bond theory explains the shape, the formation and directional properties of bonds in polyatomic molecules like methane, ammonia and water, etc. in terms of overlap and hybridization of atomic orbitals. Overlapping of atomic orbitals. When orbitals of two atoms come close to form bond, their overlap may be positive. These are the important questions. Okay, now concentrate here. May be positive, negative or zero depending upon the sign and direction of orientation of amplitude of orbital wave function in space. Very important line. I repeat. When orbitals of two atoms come close to form bond, their overlap may be positive, negative or zero depending upon the sign, phase and direction of orientation of amplitude of orbital wave function in space. Positive and negative sign on boundary surface of diagrams in the figure 4.9 show the sign phase of orbital wave function and are not related to charge. Plus and minus means it is not charge. It is just a sign. Okay, now orbitals forming bond should have same sign and orientation space. That means x-axis, y-axis type. X cannot join with y type. This is called positive overlap. Positive overlap is very good. Various overlaps of s and p orbitals are depicted in figure 4.9. We will go to the figure 4.9 now. The criteria of overlap as the main factor for the formation of covalent bonds applies uniformly to the homonuclear or heteronuclear diatomic molecules and polyatomic molecules. We know that the shapes of methane, ammonia and water molecules are tetrahedral, pyramidal and bent respectively. It would be therefore interesting to use VB theory to find out if these geometrical shapes can be explained in terms of orbital overlaps. Let us first consider methane molecule. The electronic configuration of carbon in its ground state is helium 2s to 2p2, which is in the excited state becomes helium 2s1, 2px1, 2py1, 2pz1, like this. 1, 2, this is ground state configuration. In the excited state is jumping here and 4 unpaired electrons are there, excited state. The energy required for this excitation is compensated by the release of energy due to overlap between the orbitals of carbon and the other atom. Don't worry about this, okay, how the energy is coming. Okay, that is not our business, don't worry. So these diagrams we will see. Before that, we'll complete one statement here. The 4 atomic orbitals of carbon, each with an unpaired electron, can overlap with the 1s orbitals of the 4 hydrogen atoms which are also singly occupied. This will result in the formation of 4 CH bonds. It will, however, be observed that while in the 3 p orbitals of carbon are at 90 degrees to one another, the HCH angle for these will also be 90 degrees. That is, 3 CH bonds will be oriented at 90 degrees to one another. The 2s orbital of carbon and the 1s orbital of hydrogen are spherically symmetrical and they can overlap in any direction. Therefore, the direction of the fourth CH bond cannot be ascertained. This description does not fit with the tetrahedral bond angles of 1.55 degrees. Okay, now we'll stop here. We'll come back to this by seeing this. Okay, now positive. This is very important question nowadays. Compulsory question. You see, plus done. Plus and minus. It is also okay. Okay, and this is plus. This is minus plus. Plus sideways overlapping. This is causing pi bond. Plus minus. This is also okay, but this is called positive overlap. This is called negative overlap. And this is positive overlap. This is negative overlap. But this cannot form any bond. Okay, this is called zero overlap, out of phase due to different orientation. This is y-axis, for example. This is x mentioned x-axis, and this is y-axis. This is z-axis. X and y cannot join. X and z cannot join. Y and z cannot join. Okay. So coming to our statement where we are. Clearly, it follows that simple atomic orbital overlap does not occur for the directional characteristics of bonds in methane. That means simple VBT can't explain methane. Using similar procedure and arguments, it can be seen that in the case of ammonia and water molecules, the HNH bond angle and HOH bond angles should be 90 degrees, but practically these are 107 and 104.5 degrees. This is in disagreement with the actual bond angles of 107 degrees and 104.5 degrees in the ammonia and water molecules respectively. We will discuss about this in next video. Thank you.